this talk is using past data to determine relevance in autopsy. I mentioned this morning that we're going to talk more about some of these things on such repository and discovery later on. This is that talk. This is kind of more of a deeper dive into that. So, partly there's this talk is part, about kind of what's in autopsy right now in terms of capabilities and where we're going with this. So I want to start off with some DFIR deep thoughts, and these are very mind-blowing concepts. These are amazing. I've heard people call them and refer to them as Carrier's laws, right? On par with Moore's laws. Don't ask me who's saying this. Which politicians can say this all the time. People are saying it. It's the talk of the town. Trust me. So here's the ideas. There's an increasing number of devices out there that contain evidence, and there's an increasing number of artifacts on each of these devices. And therefore, there's an increasing number of things to look at. And so the law is basically, we have more and more things to keep up with. Mind-blowing, right? Yeah, there were probably some presentations from many years ago talking about this, but this is the reality that we've been facing for a long, long time. And honestly, we haven't done a whole lot better to actually really deal with this bigger and bigger problem. So there's two general solutions to this, right? One is you add more examiners to each case. There's more devices, more artifacts, more people, get them together, collaborate, throw more resources at it. It's one solution. Second is make each examiner more efficient by, basically bubbling up what's relevant to them and making them see the relevant things and ignore all of the noise that is not relevant. So this is the autopsy talk. So autopsy is actually making progress on both of these things, right? We have multi-user cases for a while. You can have multiple examiners looking at the same case, different data sources in a multi-user collaborative environment. They can tag things, see it, joint reports, whole bunch of things. So we've been working on that problem for a while. And then we started to focus more in the past year or so on kind of the analytics of basically using past data and past things to identify what could be relevant and trying to figure out what those little pieces of relevance are inside this bigger and increasing data set. Today, we're going to focus on the analytics. We've talked many times in the past about kind of the multi-user collaborative features. Right now, it's all about analytics. So analytics, basics. Right. So the ultimate goal of all of this, at least in our mind, for how to make examiners more efficient is to assign a relevance score to the files and the artifacts that you have to look at as part of your examination. So we need some kind of analytics to assign that score. Low score to look for the things that are common and not relevant, some kind of high score for things that are likely relevant. There's a bunch of research needs to be done on how we do these things, and there'll be a variety of techniques depending on what you have, on what they are. But generally, there's a core concept here, all these things, that all these analytical techniques rely on your past cases. Past cases are critical, and everyone else's past case are critical. The past is important, right? Everything we do pretty much is based off of past cases, right? We are trained how to do forensics and DFIR based on what people before us have done as part of their investigations, what they've learned, they pass that knowledge on, and that kind of past experiences moves forward, right? Our tools parse data that was useful in past cases, and we automate that to make that useful moving forward. The NIST NSRL and other hash sets contain hashes that someone in the past thought was useful and could be ignored or focused. Same with child exploitation hash sets are kind of known as the material from past cases that are known to be bad. IOCs are from past cases, etc. We basically, a lot of what we do is based off of bringing that past cases and past information into our current cases. So basically, a lot of what we do is all about remembering the past. So there's a very famous quote out here. Again, very, very old, very famous quote that says, those who cannot remember the artifacts they saw before are condemned to analyze them again. Guy Carrier said this very long ago, early 2020. It's a very famous quote. It was later followed up by this guy, Santayana, about those who can remember the past are condemned to repeat it. But same idea, right? Why do these things over and over again? So basically, you need your tools to remember as much as possible from your past cases, right? We can only do so much with our brains, right? Computers are much better at recalling what you saw and taking advantage of that. So let's look at what autopsy's been doing to kind of help with that goal. So what is autopsy? I'm assuming most people have been here all day or most of the day or in and out, but At this point, we probably know the basics of autopsy, right? It's an open source platform designed for ease of use, extensibility with frameworks, hard drives, media cards, all the basic things, right? We already covered this. You saw a bunch of modules. You're probably sick of seeing autopsy at this point. So autopsy has what we call short-term memory, or I call short-term memory, which is basically the case that you're currently analyzing. There's a database that stores all those kinds of things, but it's also the long-term memory, right? And the central repository serves as autopsy's long-term memory. It spans cases. It keeps track of the things you've seen before. You can create this as a SQLite for your own self or as Postgres for multiple users to collaborate on that. It's pretty simple to set Postgres up. You just get a server, install Postgres, it's a basic configuration, and then your whole team can leverage that and reuse that same data. So the CR stores a few things. It's going to store identifiers from your past cases, such as file hashes, email addresses, USB device IDs, Wi-Fi SSIDs, web domains, ICC IDs, a whole bunch of identifiers can get stored inside the CR. There's an options panel. You can turn some of these off and on. If you feel more comfortable with hashes and less comfortable with ICC IDs, you can tweak these settings to kind of enable or disable certain things. Along each of those instances, we will store as well the case name that they came from, the data source name, and the path of the file that they were found in. If you make a comment about that later on with tagging, we'll store that. As well as if you tag the file, we'll keep track of the fact that you marked it as being notable or suspicious or whatever. So it's been out for a while. We first released this back in 2017. It was kind of a POC off to the side for quite a while. As I mentioned this morning, as of this past year, it is now enabled by default when you install Autopsy. So current architecture looks like this, right? We got Rensic in the middle. This is our Autopsy. The current case, it's got its case database on the left-hand side, and the historical data that you're bringing in to each of your investigations is on the right-hand side, where you have the CR, the repository of your past cases, as well as the keyword lists and IOCs and hash sets that you bring in from however you get that information and collaborate for that. So how is a CR updated? The repository, central repository ingest module is responsible for putting data in there. We saw this morning. It used to be called correlation engine. It's now called central repository. Essentially, it's a module in the pipeline. If you recall that graphic for the module competition, as files and things come down the pipeline, this module will take that hash value and will throw it into the CR for future reference. If you have it configured, it'll also query it to say, hey, has it been seen before? And if so, was it tagged? We'll talk about that a bit later on. But essentially, the ingest module is responsible for putting all those things in the CR for future use. When you tag an item, so in Autopsy, you can right-click on the file. You can say add file tag, pick a tag name. Some tags in Autopsy are considered notable, right? When you make a tag name, you can configure if using this for notable things or not. If you mark it as notable, we'll keep track of that in the CR so that it knows that, hey, this file existed and the person thought it was bad or notable, and it can keep track of that. So we can use that data in a few ways. So for quite a while, for the past 3 years, we've always had this feature. So essentially when new files come in and new artifacts come in, it'll automatically mark files as that were past marked as notable. So if a case 2 years ago or whatever marked a file as being notable, and that comes back in again, we'll automatically flag that. And you can see that in the tree. It says previously tagged as notable and gives you those items that were there. So this is basically a dynamic hash set, right? Some labs probably still have this policy. It was pretty common long ago. At the end of your case, you would make a hash set. You'd export all the hashes of the files that you tagged, and you'd add to your hash set. And the basic idea was, hey, you thought these were bad now, make sure you see them again in the future. And it was a very manual process of manually making hash sets. This is basically now a dynamic hash set that you just have to tag it, and it keeps track of this for you for future cases. One other kind of note there, there's other things that we will also flag. So things that are unique, like the USB device ID, will automatically flag. If you want to know if these two computers had the same USB device ID before, if you don't want to do that, turn it off. It's fine. This is why these things are different. We don't flag things like Wi-Fi SSIDs. They're too generic. The fact that someone connected to Starbucks or whatever isn't very relevant. So Wi-Fi SSIDs aren't currently flagged as marked at this point. It's more based off hash values. So the other place you'll see this data is in the past occurrences table. So when you're in autopsy and you're clicking around, there's a table in the upper right-hand corner. There's a couple columns, S, C, and O, plus whatever else is in there for that artifact or file type. S stands for the score. That's an evolving feature to kind of show you the score of the item. C stands for comment. There's a comment for that. You'll see a little yellow notepad, and you can see there's a comment there. And O is for occurrences. So this basically tells you that there are 4 past cases with the same hash value as this. And this basically allows you, as you're viewing through things, you can get some idea on what is unique and never been seen before and what is pretty common. So as you're just looking into a folder and you're browsing around, you can sort on this column or just kind of keep a reference for this of some idea on what in there has been seen before and what is kind of what is unique. Another way you can see this data is in the lower right-hand corner. This is the past occurrences viewer. So the basic idea here is that the bottom right-hand corner shows you an item that you've seen, that you selected, and you can get more details. So there's a tab called past occurrences, and this will go into the CR and bring back all the information about the past cases that had the same file or domain or whatever. So this is basically kind of a multi-column display here. First column is all about cases, data sources, and file names. So you can kind of dive in here to kind of figure out where else it was seen. Use case here is really kind of on perhaps making connections with past cases. Now this kind of thing makes people nervous sometimes. If their search warrant doesn't really allow that, or they're concerned it may violate that. So this is kind of where it's more of maybe tying things back or not. So again, this is more for correlation, but you can still leverage central repository data if you ignore this feature or don't use this feature on here. So that was kind of the original goal. So for the past 3 years, those basic concepts have been there, right? We're going to flag what you saw before and tag it as notable. We'll show you where we saw it before. There's some other kind of search features in there that kind of try and find common data sources and match this one up with that one. Other stuff we're not going to talk about today. We don't have time. But that was kind of the idea, right? It was all about correlation. How do we correlate this data source, or this case, with a past data source? But we're back to the original topic here. We've been focusing a lot more on kind of this big data overload problem and how we kind of get the most relevant files to you first. I like to think of forensics kind of search right now as very much of like the Alta Vista days. For those who remember Alta Vista, back in the 90s, right? It was the first search engine that like had the entire internet indexed, but you search for something and you just got pages and pages and pages of stuff, right? And then Google came in and said, we'll show you the same stuff. We're just going to rank it better. We're just going to give you more relevant ones on page 1. I feel like forensics is still in Alta Vista, right? We're still in the days of just like, blah, right? Good luck. So what we really want to focus on, we're trying to do is kind of this idea of ranking. So one way that we can use the CR for ranking is basically on how common or unique this file is. Here's the theory. If you've seen the file 10 times before and you didn't mark it as relevant or tag it before, it's probably not relevant the 11th time either. So we're going to deprioritize that from the file that you've never seen before and never ignored, therefore. Similarly, if you've seen a file 50 times before, that's going to be even less relevant than the file you've seen only 5 or 10 times before, right? The more you've seen it and the more you didn't care about it, the less interesting it's probably going to be in your future cases. That's it. It's the basic idea, right? So the central repository, its original goal was all about correlation. We've realized has allowed us to implement this kind of capability of basically allowing you to focus in and hone in on the unique things and the relevant things and deprioritize the common and boring stuff that haven't made their way into yet, for example, the NSRL or other kind of hash sets that keep track of officially known ignorable things. So to fully use this, we needed a new search interface in Autopsy. Autopsy was very much around basically kind of the 3-panel view, which was more of like, we're showing you everything, right? You should have access to everything. We'll show you everything. So Discover UI is a new search UI in Autopsy. There's a couple screenshots this morning we talked about. The goal is to allow you to, as easily as possible, to find what you're looking for and get it. So quick note here, this is an incrementally evolving feature. We have quarterly releases with Autopsy. I am very much the opinion, and therefore we are as well, about get stuff out quickly, get something out, get some feedback. and not just kind of hold on to stuff for too long. So every quarter, it's an evolving thing. So far, we've changed it every quarter to kind of meet new and evolving ideas with this. The basic process here is the user picks what features and file types they care about and how they want to display the results. There's some display options here. And basically the CR, the repository, allows the user to kind of search or display things using past occurrences as one of the features of that search. So here's an example. So an example you may have for pictures, right, is to see all unique or rare pictures that are big or medium and big, and organize them by parent folder. So as an example, we have a couple of customers who go through a lot of data. We've had this central repository set up for quite a while in most locations. So there's kind of years of data available. And if you look at this now, you can say, hey, I want to see all pictures. And it shows you a bunch of pictures, right? The kind of, without ignoring the CR, it shows you a bunch of pictures. As soon as you start kind of pulling in some of these things of, you know what, I care more about, big ones or medium ones or, rare ones or common ones or whatever, having that as back-end data really allows you to much more quickly focus in on things that are relevant and get rid of files that aren't officially from Microsoft or Adobe or things you get from the NSRL, but still not relevant because they're on so many web pages or other kind of applications that they become uninteresting. So for example, so we can focus on the rare pictures that are big, organized by a parent folder. This is basically saying, hey, I want the big, unique pictures this person may have taken or received, and I want to organize by parent folder because maybe this person had some organizational structure and it's a way of categorizing results. Or you can say, show all big pictures, but organized by frequency. In this case, maybe you want to see all the big pictures regardless, and first focus on the unique ones, and then after that, go down to the kind of more, maybe you've seen them a couple times before, and they get more common, but you can kind of prioritize your limited time to focus on those unique ones first. So here's the UI for that. You first pick the file type. Right now, it's kind of images, videos, documents, and also domains. We'll see that a little bit later on. You pick things like what size you care about. The bottom area here changes depending on what you've chosen. I just realized it's an old screenshot that this should have domains right there. So this bottom area changes depending on what type you choose. So these sizes are relative for pictures. There's the past occurrences. If you have the NSRL configured, that's an option as well. You can look for other things about, I want to see only things that are from hash sets or interesting items or have objects in them. Remember back to the module slide before, the DOI module submission, if they make the right artifact for object detection, this will be included here. So the idea here is that other modules can also feed data into this that you can use as part of your search criteria. If there was an object here for guns or cars or dogs or cats, you could choose them and include only ones that have that kind of object in them. You pick how you want to display them. We're going to group things. I don't like infinite kind of things of scroll bars of infinite thumbnails or various things. So we're going to group them based off of file size or occurrences or folder. You pick how you display them, and you get results. So in this case, the groups on the left-hand side. So in this case, we organized our pictures by size. So these are all the large images. The next group is the medium ones. If we chosen small or whatever, they'd be down here. The pictures in that range are all up here. In this case, this picture was here twice. We're only going to show it to you once, but you can see down here there's 2 occurrences, and the bottom view gives you kind of all the details you need, you want to see about that file. The top area changes. So if you've chosen a video and did a similar search for video, and the file size will change for videos, it'll give you kind of a 4-panel sequence for that. If you choose documents, it'll also give you the a document form. This area is a little bit different. It's now going to give you kind of a summary of the text up here. You can click on it, and the bottom will give you kind of the full details, of that. We do have a module. I was hoping to get it actually released, for this this conference, but we weren't able to. But it's actually a summarizing module that allows you to kind of go through the sentences and uses some, general algorithms for prioritizing sentences, and gives you the top 3, 4, 5 sentences in there to kind of make them more relevant and just showing you the first 4. So that will be up by the end of the year. We didn't get a chance to actually get it all packaged up for today. So web domains are another kind of core problem or challenge. right? Because there are thousands of web artifacts that are part of any kind of investigation. And the types are often related, right? Person goes to one website, they're going to have cookies, they're going to have history, they're going to have a whole bunch of stuff. And there's just overload with these things. So an artifact-driven perspective, right? Just looking at history, just looking at cookies, doesn't really work, right? There's too much, and it's hard to kind of figure out what the bigger picture things are. So we took a challenge on by making a domain perspective view in this Discover UI. So basically allowing the user, the examiner, to focus more on domains and then dive into, all right, well, what are the artifacts that actually support that domain that are there? And again, we're using the repository to help keep track of which domains are interesting. Now, domains are a bit more challenging than files because if you see the same file over and over again, it's probably pretty boring. Domains aren't exactly the same thing, right? Everyone's going to see Google over and over again. But again, that means Google is kind of boring, right? In some ways, right? The search terms may be relevant, but you may not want to have to go through, thousands and thousands of Google items. You want to kind of maybe focus on some other things first and then go to Google. So again, domains are a bit different, but again, having all this data allows us to start to figure out which ones are common, which ones are rare, which ones do you want to focus on as part of your investigation. So again, the central repository stores for each case that there is a domain. So the module will parse web history, web cookies, all those things, and pull out the domain from those artifacts and put them in the CR. And then the CR will keep track of that. And if you tag a web bookmark or web history or download, that also gets tagged into the CR. And again, in the future, a download comes in, it gets flagged, and we can use that as part of the discovery of kind of just looking, having that background knowledge. So in this case is this view. You pick what data sources you want to include, your past occurrences for how common or rare that domain is, which artifact types you care about, what date ranges you care about, and they will then be shown as part of that. Here's an example. The domain one is a classic example of kind of the incremental releases. The last release that came out a week and a half ago, 2 weeks, had the first version of domains. It's kind of a work in progress. The next release that comes out in January really kind of ties it all up. But what you can see here is this was organized by visits. So there's some sites here that had basically, maybe just one cookie, but no history, which is usually what the 0 visits mean. The person actually never went there, but they somehow got a cookie, from there. So you can see the groups. The next release will group these. So the next release will be more like 0 to 10, 10 to 50. There'll be kind of more broad groupings for that. But the basic idea here is that we have groups on the left-hand side, and it shows you what domains there are that have that many visits. This is grouping based off of number of visits. So if you care about their popularity, this is how you can get that. Over here on the right-hand side, we have question marks here. If there was a cached image for that site, it would be shown here. Not all sites are going to have cached pictures. Sometimes they're deeply embedded in various things. But if there's a cached image, it'll be shown here on the right-hand side. In the next release, this is what you see here is actually kind of the code that we have running in the lab. This is basically once you pick that domain, you can then dive in deeper. So in this case, we clicked on a domain, that we can click on the cache tab, and we can see here all of the cached files for that. And there's a bunch of pictures here, and we can view them over here to kind of find out what those cached pictures were. So again, you can kind of go through this, see this domain is interesting, click on this, and dive in deeper for more details. So let's get back to our original kind of problem here, right? Which is kind of the data overload, how to deal with this. So far, we've been focusing on using that past data to suppress the boring and common items, and using that past data to kind of flag what was previously notable. And the really big thing or gap at this point is also on more analytics to rank what is left over. And this is where things like object detection, text classification, clustering, a whole bunch of other kind of analytics, some of which we saw this morning as part of the submissions, can really play a big role in making sure we get that data. One more kind of thing on this thing, I want to kind of provide a quick intro for. So the central repository is all about your history, right? It knows what you've put into it, what past cases you've analyzed and gone through. And that's good and bad, right? It's bad because you haven't seen everything before, right? And it may take a while to build up your data. But it's good because something's better than nothing. and there's many labs that are offline, and that's all they're going to have access to is their kind of little silo. So Cybertriage, though, kind of has gone is going a step beyond that. So Cybertriage, as mentioned before a couple times today, there's the sponsor channel. It's basically an automated intrusion forensics tool. It started its life off as an autopsy module. It went to its own thing. It's kind of coming back into it, but it's basically hyper-focused on just intrusion-related artifacts. And basically it scores them. It's got a big scoring infrastructure on identifying artifacts as being bad or suspicious and keeping track of these things. So here's a screenshot for that. This isn't really a Cybertriage talk. This is basically it. A lot of the same back end as autopsy. A lot of similarities, but it's kind of different UI, different workflow. So it's been building up a kind of a global repository for file hashes. So Cybertriage has an online file reputation service that you get as part of your subscription to Cybertriage that basically tells you if a file is good or bad or suspicious. It's backed by Reversing Labs, the virus total link service that's got 40+ malware scanning engines. But with that, we've also been storing anonymous data, not tied to anybody, but it's basically kind of about what hashes are being requested, with the goal being about kind of frequency of how common or rare is this file actually being seen. And the plan here is that in 2021, we're going to start providing kind of frequency analysis results. Is it unique? Is it rare? Is it common? Just to give you some kind of idea on these kind of items. And so as part of that, there will be an autopsy module that will be able to leverage that kind of data and give you access to kind of this more global level things beyond just what you have in your repository. So architecture will be like this, right? This kind of your local databases here, and then kind of it can interact with this global repository to get information about, how common or rare something is. It won't tell you who had it. We're not even sure who has it anymore, right? It's all kind of been anonymized and decoupled from the actual kind of association. The next step beyond that is actually things beyond file hashes. File hashes are pretty simple in some ways, right? You hash it, we know what it is, but there's other overload problems we have to deal with. So we're going to extend this to things beyond just file hashes to include startup items, processes, a whole bunch of things. There's thousands of kind of processes you may come across, or hundreds of startup items. Knowing which ones are good or bad can be very hard. So the goal here is to kind of make the equivalent of a file hash for other kind of data types. So they still have some kind of, they're small, and we can kind of keep them as somewhat anonymized and simple. So for example, a startup item, maybe we just want to hash the path of that startup item, that executable, and we'll redact it to kind of remove the username in there if it's app data. So maybe we'll just kind of SHA-256, the users, remove the name and kind of, the path to there. Bunch of details to be determined. That's kind of the main direction that we're moving forward with to kind of allow this kind of collection and repository for all the data you're looking at to make your life easier for future cases. So basic summary of this whole thing is that we all need solutions to deal with kind of the increasing amount of data that we're getting. Sarah's talk is a great example of that. There's all that stuff great stuff she found as part of kind of the Apollo stuff, but you still have to find a way to actually get through it. And I believe that saving your data is one part of that solution to actually figure out how to ignore and suppress down all the things that you have as part of that. Discovery UI is one of our first steps leveraging that. This will be an evolving feature. I'm sure next year we will have updates on this solution as well. But I just want to make sure you guys are aware of it. And if nothing else, turn your CR on to start getting more data. So when you do want to use it, you have it there. And of course, remember the amazing quote of those who can remember the artifacts they saw are condemned to analyze them again. So thank you. You can get Autopsy, you can get Cybertriage for that. I am out of time. That's all.